Hi guys, so today the topic of our discussion is glycolysis, and this is very important topic for the USMLE, for the plab, and for also for the second year MBBS course. So in this topic we are going to study about how we can remember this reaction. You can see these are the lot of reaction in this process, but we will have a mnemonic for this, and we will try, and I will explain each and every aspect of a question which can be asked in this topic. Okay, so let's start our topic. So we have the glycolysis process which start from the glucose. Okay, why glycolysis occur? Look, we have glucose and we want energy from this glucose, and this process is the way by which we can degrade the glucose to get the pyruvate, which is the end product of glycolysis. Okay, and in this process we get ATP, and also we get NADH, which further gives 3 ATP from the electron transport chain. Okay, so first of all, try how this process will occur. Okay, first, in the first step we have glucose, which is converted into glucose 6 phosphate. Okay, and then this glucose 6 phosphate is converted into fructose 6 phosphate. Okay, and this fructose 6 phosphate is converted into fructose 1,6 bisphosphate. Okay, so this is very simple. This glucose get 1 phosphate and become glucose 6 phosphate. Okay, normally glucose has 6 carbon. Okay, 6 carbon. Okay, like this. At 6 number carbon, this is the carbon where the phosphate is attached, and it become glucose 6 phosphate because phosphate is attached at this position. Okay, so we can write like this phosphate attached on the 6 carbon, so that's is the name, that glucose 6 phosphate. Okay, and then this glucose 6 phosphate is converted into fructose 6 phosphate. Okay, and this is simply the we know the glucose and fructose are the isomer of each other. Okay, so this reaction is simply the isomerization. Okay, here the enzyme which is used is called isomerase. Okay, isomerase is used in this reaction. Okay, and in the first reaction in which we add the phosphate, you should remember that in each reaction which is related to phosphate, addition of phosphate, this reaction is called kinase. Okay, so as kinase enzyme is used due to addition of phosphate. Okay, everywhere when you add phosphate there should be enzyme which is called kinase. Which kinase? Look, this is the glucose in which the phosphate is attached, so we call it glucokinase enzyme. Okay, then we have isomerase enzyme. Isomerase called the conversion of glucose 6 phosphate to glucose fructose 6 phosphate. Okay, in the next step we just add one more phosphate. Okay, at the position number 1. Okay, so it becomes the fructose 1,6. Now there are two phosphates, so we say it 1,6 bisphosphate. Okay, so this 1,6 bisphosphate, this is a 6 carbon compound. This is yield into two compound which are called glyceraldehyde 3 phosphate and dihydroxyacetone phosphate. Okay, so this is the carbon number 1 in which the phosphate was also attached because 1,6 bisphosphate and C was also attached. So here the cleavage is between 3 carbon become one part and 3 carbon become one part. This compound is called dihydroxyacetone phosphate, and this is called glyceraldehyde 3 phosphate. Both are the same. They have same structure, so they can be interconverted into each other. They have same formula. Okay, so they can be interconverted into each other. Okay, then the other reaction from the forward from this are the same reaction. Okay, we can use this and we can use the glyceraldehyde 3 phosphate or dihydroxyacetone phosphate. Okay, so I am using glyceraldehyde 3 phosphate. Now from the glyceraldehyde 3 phosphate, one phosphate is attached at 3 at one position. Normally we have like this carbon number 1, 2 and 3. This compound is called glyceraldehyde 3 phosphate. Okay, as this position 3 position has already phosphate, we add one phosphate more at the one position, so we say it now compound is called 1,3 bisphosphoglycerate. Okay, from the glyceraldehyde 3 phosphate we get the 1,3 bisphosphoglycerate. Then 1,3 bisphosphoglycerate, now this one position phosphate is removed and we just have one phosphate which is at position 3, and now compound is called 3 phosphoglycerate. Okay, and this 3 phosphoglycerate, this 3 position can be shifted to the 2 position, and one we will call it 2 phosphoglycerate simply, and which is converted into phosphoenol pyruvate, we mostly call PIP. Okay, which is converted into pyruvate. So this is the whole reaction. How can we remember this reaction? We simply use this mnemonic: good girl favor for gorgeous doctor. Okay, it means there is a girl who favor four gorgeous doctor. There are doctors and there is competition between the engineer, but a good girl favor gorgeous doctor team. Okay, and what about boys? Boys prefer polite pretty princess. This is the mnemonic. So good for glucose, G for glucose 6 phosphate, F for fructose 6 phosphate, F for fructose 1 6 bis phosphate, G for glyceraldehyde 3 phosphate, D for dihydroxyacetone phosphate, B for bis phosphoglycerate 1 3 bis phosphoglycerate. Okay, and P for phosphoglycerate, and then again P for phosphoglycerate, and then this P for PIP, and this P for pyruvate. Okay, so the why this is very important. One thing more I want to tell you, that there are two types in which ATP are produced. Okay, ATP production occur in which there is a ATP production in the reaction. We have X which is converted into Y. Okay, and ATP is produced directly in this reaction when X is converted into Y. We call this reaction is called substrate level phosphorylation. Substrate level phosphorylation. Okay, but in a reaction in which X is converted into Y and we get NADH. Okay, NADH or FADH. Okay, these reaction in which we get NADH or FADH, these when produced they go to the electron transport chain and these produce ATP there. Okay, so it means in this reaction ATP are not produced directly, they are produced indirectly. Okay, so this reaction in which ATP are produced indirectly, these are called oxidative phosphorylation. Oxidative phosphorylation. Okay, oxidative phosphorylation. This is very important question which is mostly asked: in which step of glycolysis there is a substrate level phosphorylation, and in which step there is a oxidative phosphorylation. Okay, so I am showing this reaction. Okay, you don't need to remember all of these reactions. You should remember reaction number 1, reaction number 3, and then reaction number 7, and then last reaction 10. Okay, these are the reaction which you should remember. Okay, then I was saying the reaction number 7, this reaction. Okay, so why these are very important reaction? There is a reason behind this, because reaction 1 3 and 10, 1 3 and 10, these are the reaction which are irreversible. All of the other reaction can be reversible. Okay, it means this glucose 6 phosphate and this reaction can be reversible. It means fructose 6 phosphate can convert into fructose 1 6 bisphosphate, and 1 6 bisphosphate can be converted back into this glucose 6 phosphate can be converted into fructose 6 phosphate, and fructose 6 phosphate can be converted back to glucose 6 phosphate. So this is called the reversible reaction. But this one step and this 3 step and this last step, these are called irreversible step. All other are reversible. Okay, so this irreversible step, these are called the regulatory step. So 1 3 and 10 are the irreversible and regulatory step of the glycolysis, which are mostly asked in the question which step. Okay, and you should know their enzyme, you should know all the enzyme of this reaction, but these reaction 1 3 7 and 10 very important. Okay, one reaction I write in the enzyme which is called glucokinase. Okay, and in 3 reaction we have phosphofructokinase, which is called phosphofructokinase 1. Why we called it phosphofructose? Because there is a fructose which is phosphorylated, so we called phosphofructose, and we add phosphate, so phosphofructokinase. And in which position we add phosphate? At position 1, so we called it phosphofructokinase 1. Okay, this. And last enzyme which is in which the PIP is converted into pyruvate. This is reaction is done by the pyruvate kinase enzyme. Pyruvate kinase enzyme. Okay, so 1, 3 and 10 are important because they are regulatory step. Then why 7th step is important? Because in the 7th step we have ATP production. We have ATP production, okay, from ADP. ATP is produced. And also in the 10th step we have ATP production from ADP. So in the reaction number, or in the step number 7 and 10, these are the two steps where the substrate level phosphorylation occur, because in these two steps the ATP formation is directly in the reaction. But in the step 6 we have formation of NADH. We have formation of NADH. Then this NADH will go to the electron transport chain, okay, electron transport chain, and make ATP there, 3 ATP from NADH. Okay, so it means this reaction number 6, this is the reaction in which oxidative phosphorylation will occur, not substrate level phosphorylation occur. Okay, so I am closing this whole chapter glycolysis, and I'll just give you the whole mechanism and give you the important point which are mostly asked in the Viva question and mostly asked in the MCQs. In the first reaction, you should know the glucose is converted into glucose 6-phosphate with the help of glucokinase. Okay, then 3 step is very important because 1, 3 and 10 step are irreversible, and these are regulatory step. But why 6 and 7 important? Because 6 in which there is oxidative phosphorylation, at 7 in which the direct ATP forms, so we call 7 and 10 in which direct ATP are formed. These 2 steps are called substrate level phosphorylation. Okay, and one more thing, this enzyme glucokinase, okay, and here we have another enzyme which can be used, hexokinase. So what is the difference between glucokinase and hexokinase? So hexokinase, it means it is a kinase. Kinase, I told you, kinase is an enzyme which phosphorylate the any substrate. Okay, so kinase is an enzyme which causes the phosphorylation, and hexo means it causes the phosphorylation of 6 carbon compound. Okay, it causes the phosphorylation of 6 carbon compound. So that is the reason it is called hexokinase. And glucokinase, it means this is an enzyme which causes phosphorylation of glucose. Okay, so it is a glucokinase. So in hexokinase we have different type of hexokinase. We have fructokinase, we have galactokinase, we have glucokinase. Okay, so these are the type of hexokinase. It means glucokinase itself is a type of hexokinase. Okay, so what is the difference between these two enzymes? So it means that glucokinase is only present in liver. It is only present in liver, but hexokinase is present all over in the body. Okay, so when we specifically say about the liver has the glucokinase enzyme. Okay, so this is mostly asked about the what is the difference. And one more thing, this glucokinase has more high value of Km. It means glucokinase versus hexokinase. What is the difference? Okay, so glucokinase has higher Km value and Vmax. It means glucokinase has high value of Km and Vmax as compared to hexokinase. Okay, this is the difference which is mostly asked in the Viva question. So this chapter is completed here. In next chapter I'll start about the TCA cycle, which are the important step in TCA cycle, which produce the NADH and which produce the carbon dioxide, and all of the TCA cycle I will complete in next video. So till that, bye bye.